Welcome to Silverhand Studios. I'm Chris. Today I'm going to introduce you to my first custom watch movement. Over the past few years, John Edwards and I have been talking a lot on the Off Hours podcast about all of the techniques and skills that are involved in watchmaking. And we decided a few months ago that we should take the knowledge that we have and actually put it to the test and try making our own watch movement. So a few months ago, John and I decided to embark on Project Minotaur, which is our first custom watch movement. We decided to set a few goals and restrictions on how we were going to make this movement. The first thing we decided is that we were going to start with an ETA 6497 movement. A few good reasons for this. The first is that we wanted to start with an existing movement which we already knew functioned. And we are going to replace some of the parts in this movement without replacing all of the parts in the movement. And that way, as we go along, we can test the parts that we make and make sure that everything still works. And if something isn't functioning, then we know the problem is with the parts that we've just made as opposed to all of the parts that existed in the movement and we know actually function properly. We have a long-term goal of building a complete movement on our own and of our own design. And this approach of remaking part of the movement in each iteration will allow us to build our skills as we go. The first goal is to replace the existing bridges and caulk. The ETA 6497 is a very successful movement, which has been mass-produced since the 60s, but it isn't a particularly attractive movement design. So we wanted to make new bridges and caulks, which will look better than the originals. We also want to convert this from a pin-regulated balance to a free-sprung balance. The primary reason for this is to improve the accuracy of the watch. This is also the most significant change to the original and will probably take the most work to complete properly. The first steps in this project, redesigning and replacing the bridges, is covered in excellent detail in Christian Lass's online Masterclass 1. Christian has a number of excellent courses available on how to service and customize watches, and I recommend you check them out if you're interested in more details on how to do this work.
Hello and welcome, my name is Christian Lass, and in this course I will show you the basics of building watches. When you want to build a watch, you want to be able to turn material, like raw material, like brass and steel, into watch components. And really the basics is to be able to use like a lathe in a confident way. So when you turn something out, then it gets exactly on measurements, and thereby you can make and create parts for your watch. So this in this course here, I will take we will make like a new bridge here for the watch. And this bridge here, there's many techniques that we have to use in order to create that.
Since Christian has covered replacing the bridges in excellent detail, I'll be moving quickly through those steps and will be focusing most of my attention in these videos on the techniques not covered by him. All right, let's get into the project and show off some of the details. The first thing we needed to do was design the new bridge layout for the movement. I started by printing a drawing of the original movement without bridges at 20 times real life. John and I then spent a few hours sketching out where the new bridges could be, taking into account the critical features of the movement. Once we had sketched out the shapes, I created a more accurate model in Fusion 360 so we could accurately place the new pins and screw holes required to hold everything together. Here's a comparison of the original bridge design beside the updated layout we'll be using. Along with updating the look of all the bridges, we've also decided to move the escape wheel off of the train bridge and onto its own caulk. Thanks very much for watching. Next episode, we'll start drilling the pin and screw holes, critical for accurately holding the two plates together. If you've enjoyed this video, please consider subscribing. And if you know someone who might find this project of interest, please pass it along. If you have any questions, please comment below and I'll try to address them by responding or including details in a future video. Thanks very much.